Hiya guys, and welcome back to Wade's Workshop, and this is going to be part 3 of the compound slide replacement block. Before we start, can I just say thank you so much to all the new viewers and new subscribers to my channel. Since I've started this project, I don't know why it is, but all of a sudden the viewing figures and the subscriber numbers have gone up hugely just over these 2 episodes that I've done so far. So there must be many new viewers, and a big welcome to you all. So as I mentioned at the end of part 2, the next procedure is going to be to make up the spindle that holds the tool post down onto the riser block. So I'll show you a little drawing of that and we'll go from there. So yeah, unusually I've done a little sketch. It's basically M10 on either side with a boss in the middle. So we got 25mm of M10, a boss here which is just around the 18mm mark. We'll come to measure that up with the mic, which is 11mm thick, and then a 48mm long portion of M10 again, and the thread only needs to come down about 22mm. So I'll probably just buzz through showing the highlights of machining that, and we'll go from there. At the end of the last video I was shown tapping a hole in the riser block, and my vise was loose, but as you can see I've tightened up the 2 bolts that hold the vise on the bench. I was slapped on the wrist for it, and quite rightly so, and now my vise is tight. So I've got this piece of EN8 bar. It just so happens it's that diameter is about 0.4 over on the register, and this is, well, I don't even know what it is, but I can see it's bigger than 10mm. Let's not mess about with the tool post. 11.5mm, so yeah, not too much to worry about. Now I don't want to turn it down over its entire length, so what I'll do is just touch my parting tool on the edge of that face, which I've just done a skim on, by the way. Set to 0, and the overall length of this side is going to be 48mm. So I'll just set to 48. Let's just lock that into position. There we are, 48mm. Lock my carriage, and I'm going to put a groove. Let me just check. You can see. Yeah, you can see where I am. I'm going to put a groove in here. Well, I know there's 1.5mm to come off here. If I do a groove a mil deep, then I know I'm going to be undersized. I will be parting this off. I've got a couple of mil deep. Here we go. That's a couple of mil deep there. So I've just put a couple of grooves in with a parting tool. I set the parting tool up against this space, came out 48 and put a deep groove in there, and that's the overall length of the M10 with the, well, the M10 bit is here, M10 threaded bit is here, sorry, and the 10mm plain diameter is there. And I put a secondary groove in, which is to the root of the M10 thread, to that depth. So now I'm just going to skim across the top of these 2 journals, should we call them, until I've got a 10mm diameter. Then I'll probably part this end off completely, and I will run the die up to put an M10 thread on the end. Then I can hold it in a 10mm collet, and I can turn the other end, all based on a nice large diameter in the 10mm collet, or large length of that diameter of 10mm. I think my tip is a little blunt. The finish is okay. I'm just going to skim this down. I'm taking a mil off now. It leaves 0.5 mil, and I'm going to change to my finer tips. So I'll just skim this off. Maybe a bit faster on the speed. That's better. I've got a bit of deflection in this shaft, hence why I'm going to change over to my aluminium type tips. Okay, so I'll change the tool over now for one with the aluminium tip in it, and I'll finish it by creeping up on it to the 10mm diameter. So I've got the ground tip in there now, and I'm just going to take, well, I've got a 0.1 cut on leaves about 0.3, and I'm just going to gently run across the surface to remove any deflection, and then I'll get the mic on it and see where we are. Yes, so this portion here is going to be the M10 threaded portion, and this bit here is going to be the 10mm diameter. So I'll just skim it the full length at a 10mm diameter. The finish is absolutely fabulous there. Running at 970 RPM, and I've got quite a fine bead, as you can see, but I want to remove any deflection that was there from the coarse tip with a big radius, and as you could probably hear while I was machining it, it was jiggering about all over the place because I'm stuck out a long way. I'm not steady on or anything like that. So 10mm diameter done. I'm just going to part this end off. I'm not going to go all the way through. I can go a touch more, I believe. Don't want to part this right off, because as you can see I've got a centre in. I don't like parting things off with a centre in them. But, there we go. Just snapped off the little pip in the centre. That was as brave as I wanted to get. So I just remove that pip. So I've got no support on the end now, but I should be able to just, there we go, remove the pip. I think at this point I'm going to put a centre drilled hole in the end, not too big, just a small one, so that I can pick that back up should I need to. That will do the job. I think we'll have a nice chamfer on the end of there. I'll swap over to there we go, to one of these. I wonder if we're going to get chatter. Or should I put the centre back in? Yeah. Not bad. In fact, I think we'll put it more like the angle of the... There we go. Right. So I think the next procedure is going to get the 10mm die in a die holder, in my die holder, and run a thread down there. So I'm just running the 10mm die. I've got about halfway now. I'm having to use a spanner instead of my drawbar. Not instead of my drawbar, instead of my winding handle. Purely because there's a drawbar in the headstock, and I can't put my winding handle in while the drawbar's there. I push my emergency stop because with a spanner on the end of the head, if I were to start it up and not take the spanner off, well, you can imagine, flying spanners. Big dent in the forehead. So yes, I've got into the habit whenever I've got a spanner or the winding handle. We're nearly there now. I need about another one turn to get into that groove. And I believe that's it. So that's it. Take the spanner off. That's a 10mm thread with a 10mm diameter here, which fits snugly in the tool post. I'll try the tool post on there in a moment. And I can now hold it by that 10mm, turn it round, and machine the other end. So we're going to have a boss in there 11mm wide, and then a 22mm, I think it was 22, I'll look at my drawing, of M10 on the other side. So I'm just referring back to my drawing, 25mm 36. So I'm going to part it off from that front face. So I've machined all this lot here. I'm going to part it off 36.5mm. I can just get in there with my parting tool to take it off this larger diameter. I'm going to part it off, and I know that it's 0.5 millimeter to take off the end. Right. Oh well. Off it comes. So yeah, I finished off the diameter. Let me just have a double check of that. Well, that's 10mm on the button. I don't know how well that picks up. Yeah, that's 10mm. Undercut it in there with a parting tool. Finish facing this face here. And put a chamfer on the end as a lead-in for the die. So, the next step in the procedure, much the same as last time, is to run, let me just come on to it, here we go. Okay, so the next step in the procedure is to run the die down there, much the same as you saw me do last time. So this part fits in my riser block, and the hole I bored in the riser block earlier, I've just checked it, it measures up at 18.1 millimeters. So to give myself a fighting chance, that black area is like 100th under 18.1. Now I've screwed the riser block on there, and it does just fit in here. In fact, it will remove the black marker if I do it. Now I've measured the underside of the tool post, and that measures 17.95, sorry, I didn't say. And that is a couple of hundredths under, because it has to come on and off occasionally. So yeah, a couple of hundredths under where it fits in the tool post, and like a hundredth, maybe 2 hundredths under where it fits in the riser block. So I'm going to put a chamfer on there now, on this leading edge, to make it easy to get in the riser block. And I'm just going to get in with a cutter and put a larger chamfer on this back edge, just because, to allow the lead in for the tool post on the riser block. So I'll get on and do that. So in fact I can probably do that in shot. One clip. Oh, I got my tripod very close here. In fact, yeah, I think that'll about do me. Let's just put a little chamfer on there. I'm just going to angle my tool post round a bit. I'm working around the camera here. I think I can just get in there. I can. And a larger one here. And that will do me. Oh yes, this register I put at 4.5 deep, so this smaller size will go below surface on the riser block. In fact, I can feel a little burr there. I'll just show it a little needle file. Just feel it on the intersection between the two. Okay, so I've been playing with this for a while. It was a little tight on this back face, so I've had a little bit of a fettle and a squirrel on the back. Needs a bit of a polish up yet, and oh, there you go. And that is now down hard on there, no movement whatsoever. Let's just try the handle in there. Now this is in the orientation it would be on the lathe, so the carriage runs in this direction. I'm about 90 degrees out with the handle. Now I can't bring it back there, but what I can do is bring it round another 3/4 of a turn, which is 3/4 of the pitch of the thread. Needs to be removed off. Let me just show you. Take it back off again. Of the underside of the face in this bolt. So the pitch being 1.5, 75% of 1.5 is 1.125. So of the underside of this register, if I remove 1.125 millimeters, that should allow the handle, or this thread will revolve, and the handle should come around further to lock it off in this position here, as opposed to this position here. So we'll do that next. Okay, with the bed running in this direction, the handle now stops there and it's going to be out of the way of the tailstock, everything else. Yeah, I brought it back 90 degrees from where it was by taking 1.125 off the underside of the bolt, screw the bolt in a bit more, jobs are good. So, one final job I want to do is that on the underside here, this spot is not where the little dowel that's on the swivel plate of the when you fit the compound slide. Let me just show you. Yes, so I want to have a little hole. As you can see, it's not in the right place. Little hole in the underside, which means I haven't got to take this plate off, or plate out every time I want to change between this and back to the compound slide. So I just want a little hole in the underside just to clear that. I mean, it doesn't have to be very large, just to clear that, so that when I change to the cross slide, I haven't got to change to the cross slide. When I change to the compound slide from the fixed block for whatever reason, I haven't got to take the cross slide off and refit this plate. So yeah, that's the plan. Get a hole in the underside of this. So quite simply, I've measured from the outside to the far side of that dowel, reduced 3mm, scribed the line, and then again measured from the outside here to the center, to the far side of the dowel, reduced it by 3mm, and scribed the line again. And I've now got, oh, I don't know if you can see it. Yes, you probably can. Little centre pot there, and I'm going to drill it with, yeah, probably a 7mm hole. So I said I was going to polish up, you know, the faces and what have you to make everything look nice. And I have been asked before how I go about doing that. Well, I've got a good sharp file here. It's not a coarse file, it's like a medium grade file. I've just cleaned it out with a file card, and as you can see, my file card, well, I've probably got more here than the file card's got bristles. Anyway, that's another story, but it goes to show that it's been well used. So yeah, I didn't explain myself. Nice clean file, cleaned out with a file card, and then I used some French chalk. It just helps stop the file clogging up, or the clog filing up, as I nearly said. So yeah, if I got a surface like this, it's got the machining swirls in it still from where it was, where I've milled it off. So yeah, I'll take a file, and with a surface like this, I'll actually draw file it. So I'll use a file at 90 degrees to what you would expect, and I'm holding it like flat on the surface, flat and level, and I'll draw file it without applying a great deal of pressure across the surface. Now I just give it a tap, and that removed any of the material that's built up in the file, and I'll keep going with that until I get to a point where the machining marks have gone. Now I can also do it this way as well occasionally, just to make sure I'm not taking the ends off, and sometimes I'll use the file on a diagonal as well. And again, on the same note, I'll rotate my block, just, you know, so that if I'm putting more pressure on one end than another, I'm evening myself out, but I'm not, you know, not really pushing on the file. I'm just letting the file itself do the work while keeping it flat to the surface. So again, I will do a diagonal, and again a diagonal that way. And it takes me back to when I was an apprentice, part part of the training, I suppose, when you were in your first year, was learning how to file. And they cut us off a piece of inch and a quarter square mild steel, and they was chopped off on a bandsaw at inch and a quarter long, so I had basically an inch and a quarter cube. And the exercise was to file the cube on all 6 spaces, and it had to be square within a thousandth of an inch, and it had to be within a thousandth of an inch cube. So you had a quarter of an inch to come off on each dimension, and you had to keep everything square and to size within a thousandth of an inch. Now you can imagine, after about 4 or 5 pieces of metal later, having them been thrown in the bin by the apprentice supervisor, you soon learn to be able to file things flat and square. So yeah, that was the exercise. So there's no substitute for practice with filing. Everybody's got their own techniques. And as I say, no substitute for practice. The more you do it, the better at it you get. Don't tend to have to do a lot of filing in industry nowadays, because the machines are a lot better for, you know, it's expensive way of getting something flat. If I had a milling machine surface grinder, it would be a lot better than I've got this doing it on the lathe. But yeah, sometimes you've got to resort to the old-fashioned way, and draw filing's quite a good technique. So I'll keep going on this now until I've basically removed all the machining marks. So I'm still going, getting somewhere near now. I do have a couple of marks from the forge or chuck here, which, yeah, I'd have to reduce it by about 0.5 millimeters to get rid of those, but I'm just concentrating on getting a flat surface. So I've been draw filing it this way, and also keeping the filing contact and flat at all times. I'm not pushing down on the backstroke, I am pushing down on the forward stroke with the file. And I'm getting to the point where the swirl marks or machining marks have pretty much disappeared. Yeah, I'm not going to get these little marks out here, but you get the principle. So once I've filed it flat, I take a large flat oil stone. I've sprayed both sides, and I generally use WD-40 for this. And I'll gently rub it over the top with the coarse side. May take 3 or 4 minutes, but I'll keep going until I can't see any more file marks. All I'll see is the swirl marks from the stone. So as you can see, it's coming up, starting to shine now. I'm keeping the oil stone flat and in contact with the whole area. I mean, ideally figures of 8, but I'm just sort of doing a bit of a random orbit. And eventually all the file marks will disappear from this surface. As you can see, it's coming up reasonably shiny now, and I'm starting to see swirl marks. I can still see some witness marks from the file here and there. So I'll keep going with this, probably another 5 or 10 minutes. So final couple of steps now. I've got some coarse, well, it depends on the manufacturer, but this is coarse Scotch-Brite. And I'm just going to buff over the surface with that until I've got a regular surface. It's almost like a brushed finish now. Those little dinks in here are really getting on my nerves where I held it in the forge jaw. I really should have put some soft jaws in when I did that. I thought with it being cast we might get away with it, but anyway. So that's that. And then I've got a medium Scotch-Brite, which is a brown one in my case. So I'll do the same thing again. Just refine over the surface of that. with the medium. That's good. And I can finish off with a fine. And this will basically just buff it. I'm going to mark there. There's an oily fingerprint, something like that. There we go. Yeah. And, well, I don't know how well that shows up, but yeah, I mean, I've got a polished surface there now. So I just need to do it on the rest of the block, I suppose. Well, there it is, the finished job. I've just given it a bit of a try. Did a facing cut, parted a piece off, just put a big chamfer on with another tool. Yeah, I mean, I've got a bit of polishing up to do, and pretty much the job's a success. Yeah, I'm pleased with how it's turned out. Everything's locked solid. Time will tell. We'll have to see how we get on when as we're machining. So yeah, it's a case of time will tell, really. But all in all, I'm pleased with the end result.